specified in the problem or in your discussion, then you have to simply change the rate of interest according to the problem. I will show you how that is going to change. And time. Now the question arises: what about the time? Time can be per annum for 1 year, 2 years, 3 years, 4 years, or so on. Now, second part of this is depreciation. Depreciation means the value is decreasing. Suppose you purchase a vehicle, a new vehicle. Its value is suppose X. With the passage of time, the value of your vehicle is going to reduce. That means monetarily, the value of the vehicle is depreciating. And similarly, the depreciating rate is there. But calculation in the interest, what we are doing in interest is always added. But as far as your depreciation is concerned, it is always subtracted. Now going back to the theory, money can be lent or borrowed from one entity to another. The price to be paid for use of a certain amount of money for a certain period of time is known as interest. It is considered as an expense to the borrower and income for the lender. The money borrowed or lent is called the principal. The interest may be payable yearly, half yearly, quarterly, or monthly. The idea of interest is based on the time value of the money. It means that the money available at the present point of time is worth more than the same amount of money at a future point of time. That is why normally what we say, we should have money in our pocket. Suppose we want to purchase anything or we want to buy anything, what we do? We straight away go to the market and purchase it on cash. If that purchasing is done through credit card, then you are paying a hefty amount on the principal what you have got. No doubt it is paid at a period of 40 days, 45 days as per the policy of the bank. But you are paying some extra money. That extra money is the interest. And if you are using debit card, that in case you have to pay the annual debit card fee, but you are not paying anything extra to the shopkeeper. In debit card, money is yours, and in credit card, the money is of the bank. Interest is actually the amount charged for the borrowing of money to compensate the lender for the lost opportunity cost of not having the money and also for various risks of lending money, such as default risk. Now, we will talk about simple interest. Simple interest is denoted by SI or I. It is the interest calculated on the original amount borrowed. Thus, for the entire period of computation, interest is calculated on the principal amount. Rates of interest are usually expressed as percentage. Now, what is simple interest? Simple interest is equal to principal into rate into time. Or we can say in short PRT. P for principal, R for time and R for rate and T is for time. Now comes the amount. Amount is summation of principal and interest. No doubt, amount is always more than the principal because that value consists of interest also. You can see that A is equal to P plus I. For P, we know that it is PRT. So we will be taking P common and we will be left with 1 plus RT. That means this amount is the total amount due at the end of the P. Now we will see a problem. To buy a new car, Ramesh borrowed rupees 5 lakhs at 8% annual simple interest for 3 years. How much interest will he pay? So simple is that. What does the problem consist of? What information is provided to us? First of all, it is the principal, that is of 5 lakhs. Percent is the rate of interest. R is equal to 8%. 8% means 8 by 100. And your time is 3 years. What has been asked to calculate? Interest. You know that interest is equal to P into R into T. Simply multiply it and you will get as 1,20,000. That means for lending money at rate of interest of 8% per annum for 3 years, you are paying 1,20,000 more. That means your amount will be what? 5 lakhs plus 1,20,000. But in this problem, we were asked to calculate the interest, that is 1,20,000 only. Second problem is Himanshi lends rupees 45,000 to Rama. Find the time period for this amount to yield 9,900 in simple interest at 11% per annum. Now, there are two values given to us, 45,000 and 9,900. And time has to be calculated and rate of interest is given to us 11% per annum. The problem says that this 45,000 which was lent by lent to Rama, it amounts to 9,900. That means the interest is 9,900 on the principal amount of 45,000. Your rate of interest is 11%. 11% means 11 upon 100. That comes out to be 0.11 and time has to be calculated. You know that I is equal to P into R into T. Your time will be equal to I upon P into R. By substituting the values, you will get time period of 2 years. That means for 2 years at 11% per annum, 9,900 is the interest what has to be paid by Himesh to Rama.
Excuse me, sir.
Yes, sir.
Can you come again on the finding time?
This one.
On the calculation explanation on finding time, I'm a bit behind.
Okay. So calculation can be done later on, but you have to understand the concept what I'm doing. Once you have completed, please inform me so that I can proceed.
Okay, done, sir. Thank you.
Okay, now another problem comes. In how much time will rupees 70,000 becomes rupees 22,100 at 10% per annum simple interest? It's very clear that the principal amount is 17,000 and it is becoming. That means it is the amount. Amount is 22,100. Rate of interest is 10% per annum. And you have to calculate at simple interest. That means how what has to be calculated? Time has to be calculated. We are given with principal, we are with amount, we are with rate of interest. Rate of interest is 10% per annum means 10 upon 100, which comes out to be 0.1, and time is unknown. We know the formula. Amount is equal to principal into 1 plus R. We have to substitute the values. Open up the bracket. You will get 1700t is equal to 5100. That means time will comes out to be 3 years. Whatever information is shared in the problem should be written in terms of the topic which is being discussed. Here, you have to be very careful to understand which amount is more. Keep one thing in mind, amount will always be more than the principal. Rate of interest will always be in percent per annum, in percent in general, and your time will be in years unless and until stated. Now we move to compound interest. This is another type of interest. Compound interest is calculated not only on the initial principal amount but also on the accumulated interest of previous period. In other words, compound interest is calculated on interest as well as the principal. Therefore, compound interest is sometimes described as interest on interest. Banks always lend you money on compound interest. Some concepts related to compound interest. Compound interest is the difference between the compound amount and the original principal amount. Now, what another term is compound amount, the total amount due at the end of the last period. Third one, frequency of compounding. It indicates the number of times the interest is compounded in 1 year. It is monthly, it is quarterly, it is half yearly, or it is yearly. Then comes compounding period, the time period between the two consecutive points in time at which interest is compounded. Now, again, mathematical re- relation is there. Formula for calculating the compound interest. That is, we always get the amount over here. Amount is equal to principal into 1 plus r raised to the power n, where I is the rate of interest and n is the number of period, months, or whatever is mentioned in the problem. Now the thing is that I, what is I? I said R once, now I am saying I. I am replacing I by R by K. Or in other words, we can say that that is the annual rate of interest divided by number of compounding period per year. For example, if annual rate of interest is 10% and the compounding is quarterly, then there are four compounding periods per year. That means 12 months are divided by 4. The rate of interest I will be equal to what is 10%. The rate is 10% compounded quarterly. That means 0.10 divided by 4, which comes out to be 0.025. If the annual rate of interest is 24%, and it is compounded monthly. Then in an year there are 12 months. So what we will be doing? We will be dividing 25% by 12. That means 0.24 divided by 12, which comes out to be 0.02. Now we see a sim- what are some formulas for compound interest. If the rate of interest, if the time is yearly, we will straight away use 1 plus amount is equal to principal into 1 plus I raised to the power n. Now, if the rate of interest is half year, so what we will be doing, we will be changing I by R by 2, and your time, that is n, will be replaced by 2t. If we talk in terms of quarterly, so I will be equal to R by 4, and your n will be equal to 4t. If we talk in terms of months, then your I will be equal to R upon 12, and n will be substituted as 12t. Compound interest, whatever the condition is, interest will be equal to amount minus principal. Just let me know, can any one of you, after hearing this discussion, can you tell me, will compound interest be more or simple interest be more on a particular sum of money? Will the amount will be more in simple interest or in compound interest?
According to what I've understood, I think it will be more in simple interest than compound.
Madam, I told you that compound interest is interest on interest. No doubt that compound interest will be more because compound interest is being paid by you. You have seen many problems. You have heard of so many problems right now that amount is more. But if we talk in terms of compound interest is more than simple interest. The bank pays you simple interest, but bank takes from you in compound interest.
Okay, sir. Thank you.
Now see, a bank pays compound interest at the rate of 5% per annum. You have to be very careful now to see what is given there in after percent. If nothing is mentioned, it is understood as per annum. If per annum is given, then it's okay. But you should be aware of what is given after percent. Yogi deposited a principal amount of 5,000 in bank for 4 years. Find the interest that Yogi will receive. Here principal is 5,000, number of years is 4, interest is 0.05, that is 5 upon 100. You are being asked to calculate amount. Amount is what? Amount is amount is equal to p into 1 plus r raised to the power n. Now we will add this 1.1 plus 0.05, which comes out to be 1.05. 1.05 raised to the power 4. That means 1.05 has to be multiplied by itself 4 times. So you can take this value from the compound interest table, which will be at the end of your study material, if I'm not wrong. After multiplying it, you will get amount is equal to 6,077.5. This is the amount. But what was asked by you to calculate the interest? I told you amount is always more than the principal value, and the difference is the interest. So interest is equal to A minus P. Here A is 6,077.33 and your principal is 5,000. After subtracting, we get 1.077.5. That means you will get rupees 1,077.53 as interest from the bank. If an amount of rupees 86,400 is invested at 8% per annum compounded quarterly, how long will it take to accumulate 2,06,500.60? Now, your principal amount is 86,400. Your amount what you will be getting is 2,06,500.60. Your rate of interest is 0.08, that is 8 upon 100, and you are being asked to calculate time, that is unknown. Now going back to the problem, you see that it is mentioned as 8% per annum compounded quarter. How many quarters are there in the year? 4. That means rate of interest will be divided by 4. This comes out to be 2. Going back to the problem, what you are having? You are having 2,06,500.60 equal to 86,400 multiplied by 1.02 raised to the power n. N is the time what you are being asked to calculate. Now after dividing this, your simple thing will be 1.02 raised to the power n equal to 2.39005. Now we will be using log table. So by log, property of the log, what has been discussed to you when I was discussing in my earlier session how this log is converted or calculated. So we will get n log 1.02 equal to log 2.390056. Log 1.02 is 0.0086 and log 2.390056 is 0.378408. All these values are available in the log table. After for calculating n will be 0.378408 divided by 0.0086. After that you get 44. That means divide this 44 by 4 because your rate of interest is compounded quarterly. You are getting 44 quarters. 44 quarters means 11 years. That means the required time will be 11 years. Now we will talk about some special cases of compound rate of interest. Continuous compounding. We have discussed various cases where interest was compounded monthly, quarterly, semi-annually or annually. But what if interest is compounded daily or hourly? When the compounding period becomes very tight and the number of compounding periods per year grows or infinitely large, it is called a case of continuous compounding. In such cases, the interest is calculated and added to the principal amount every extremely small time period, such as hourly or minutely. What is the formula for calculating continuous compounding? That means here amount is equal to principal into e raised to the power rt, where a is the amount, b is the principal, r is the rate of interest, and t is the duration in years. If a businessman invests rupees 50,000 at the end of an annual interest rate of 5% per annum compounded continuously, calculate the amount he will have in the account after 5 years. Here, your principal is, you can see that a word is written that 5% per annum compounded continuously. This itself shows which formula will be applied. For this compounded continuously, you have to apply the formula amount is equal to principal into e raised to the power rt. You have principal of 50,000. Your rate of 0.05%, your time is 5%, and you are being asked to calculate the amount. Amount is equal to 50,000 into e raised to the power 0.05 into 5, which comes out to be 0.25. The value of e raised to the power 0.25 can be taken straight away from the exponential table. When you will be multiplying it, you will be getting amount is equal to 64,200. That means for investing rupees 50,000, the amount will be 64,200 at 5% per annum compounded continuously condition for a period of 5 years. And the interest paid is 14,200 because amount is equal to principal plus interest. Now we move to unit 11. Unit 11 is compounding and discounting, nominal and effective rate of interest. An interest rate is only meaningful in the context of time. In general, it is understood as per year rate, which may be called nominal interest rate, with other periods of time and other periods than a year, like month, week, or day. The interest may be called as effective interest. Suppose we have an amount A is invested at interest rate of I per year, and this interest is compounded annually. After 1 year, the amount will be A is equal to interest into I. That means A into 1 plus I. And this total amount will earn interest on the second year. That is what I said, interest on interest. Here is that what that phrase interest on interest means. If after n years of period, your time will be your amount will be A into 1 plus I raised to the power n. This 1 plus I raised to the power n is called as accumulation factor. If interest is compounded daily after the same n years, the amount will be, now see to it very carefully, which we have done earlier also, amount into 1 plus I upon 365 raised to the power 365 into n, where I is the case of nominal annual rate of interest. Now comes your effective rate, annual rate. The effective annual rate of interest is the amount of money that one unit invested at the beginning of the year will earn during the year when the amount earned is paid at the end of the year. Amount is always paid at the end of the year. In that case, how to calculate rate of interest? Here, R is equal to 1 plus I raised to the power k minus 1. That means you have to remember the basic formulas and you have to be sound to understand the problem, what is given in the problem, and what you are asked to calculate. Here, your R is the effective rate of interest, small r is the annual rate of interest, K is the number of compounding periods per year, and your I is the interest rate per conversion period. Here, if the nominal rate is compounded continuously, the formula for effective rate will become R is equal to e raised to the power r minus 1. That means 1 plus I raised to the power k is being converted as e raised to the power r, and minus 1 remains the same. Now find the effective rate. which is equivalent to a nominal rate of 12% compounded quarterly. Here, A is equal to 4, R is equal to 0.12. Your capital R has to be calculated, and your I is 0.12 divided by 4, because in an year there are 4 quarters. Going back to the formula, this comes out to be R is equal to 1 plus R by K raised to the power K minus 1. Your R by K is 0.12 divided by 4, and your K is 4. After calculating all these values, you get 1.1255 minus 1, which is 12.55, which means 12.55% is the equivalent effective rate. Now, we'll move on to what is meant by present value. Present value describes how much a future sum of money is worth today. To see the underlying idea, suppose the objective is to have an amount A after n years from today. If the rate of interest is I, how much should be deposited now so as to achieve the set target? So, the amount required will be A is equal to 1 plus I raised to the power minus n. Such a quantity is called the present value of A, and the factor 1 plus I raised to the power minus 1 is called the discount factor. That means your P will be equal to A into 1 plus I raised to the power minus n. This n can be converted as P into K. Now the question is, what is this n means and what is this K means? K is the number of compounding period per year. T is the time duration in years. Your n will be number of compounding periods. Everything will be available in the formula. And how to calculate the present value or continuous compounding formula. That is A is equal to P is equal to A into e raised to the power minus RT, where P is the principal, A is the amount, R is the rate of annual rate of interest, and T is the time duration in years. Now see, one problem has been taken and both the things are being calculated. The concept is to make you understand how the values will change when the rate of interest is paid yearly and half year. Suppose what is the present value of rupees 1000 due in 2 years at 5% per annum compound interest if the interest is paid yearly and half year. Now what is given to you? Amount is 1000, I is 5 by 100, that is 0.05, and is equal to 2 years. What you have to be find the present value, that is P. P is equal to A into 1 plus I raised to the power minus n. You have all these values with you. A as 1000, I as 0.05, and n as 2. After calculating all these values, you are going to get 907.03. That is the present value for 1000 for 2 years at 5% when the interest is paid here. Now we will be shifting this in the second part when the rate of interest is paid half year. So first of all, what is the first step? In R, that I will be, there will be change in R. We will be changing this I by, that means we will be dividing this I by 2 because half year. That means 0.05 divided by 2. And the time period N will be multiplied by 2. You have 2 years. That means we have 4 quarter years. Substitute the value. You get 1000 into 1.05 raised to the power minus 4. After getting the value, you get 906. That means the present value is 906 for rupees 1000 for a period of 2 years at a rate of interest of 5% compound interest. This is how the calculation is done. You have to be very careful in having or in for taking up the values, because initially in the problem it is 5% per annum compound interest, and the interest is paid yearly and half year. Formula remains the same: time period and the rate of interest change. We cannot change the amount, we cannot change the principal, nor we can change the interest. Now comes discount. Simply, it is understood that discount is always given on the principal. The concept is the same. You go to the market to purchase something. The shopkeeper says to you that it is for X rupees. Then you have a word with him and you ask them to reduce some amount. So what he normally says, the shopkeeper normally says, okay, I will give you a discount of 10%. He is giving them discount of 10% on what? On is the selling price or on the cost price? He is paying you a 10% discount on that selling. That means this amount will be deducted. Discounting is opposite of the compound. When we know the future value of some amount or obligation, we apply discount rates to find its value at the same earlier date. So discounting is all about moving backwards in time. What are the different types of discount? That is simple discount. Sometimes interest rate is paid or deducted upfront in the financial transaction. Such interest is called simple discount. Formula for simple discount, no doubt it will be given by D. D is equal to A into D into T. Simple discount is always represented by capital D, and your small d is the discount percent. A is the amount at the end of T period, and small t is the total time. If we talk for finding the present value at the discount rate, then see the difference in the formula. Principal of the present value is equal to A into 1 minus D raised to the power n, where D is the discount rate, n is the number of time period, and your A is the amount, and P is the present value of the amount. No doubt discount will be A minus P. Then comes your compound discount. Compound discount is the inverse of compound interest and is used to calculate the value of future value of an amount at the earlier date. The formula for calculating the compound discount is P is equal to A into 1 plus I raised to the power minus n, where P is the present value of the amount, A is the amount at the end of n periods, your I is the interest rate per period, and your n is number of time period. Then comes continuous discount. In continuous discount, the formula will be what we will be using. We will be using exponential term. Continuous discount is used to find the present value of an asset or an obligation whose value is known at some time, future, when interest is compounded continuously. The concept of continuous discounting has wide application in valuation of futures and forward contracts. The formula what we will be using for continuous discount is P equal to A multiplied by E raised to the power minus I into N. You are aware of all these values meanwhile. P, A, I, and N. Now, how to use this one? We have to find the present value of rupees 5,000 in 2 years at the rate of 4% per annum of discount compounded to 100. Here A is 5,000, N is 2. We talk in terms of quarterly, so we will be multiplying it by 4. T will be 0.04 divided by 4. You are being asked to calculate T. T is equal to A into 1 minus D raised to the power N. Your A is 5,000, D is 0.01, and your N is 8. On calculating, this value we get as 0.99 raised to the power 8, whose values can be taken from the table, which comes out to be 4,630. That means the required present value will be 4,613.72. That means value is correct. Now, with this, we come to the end of your part A. Now, we will be starting with part B, that is business statistics. We'll start with univariate analysis, that is your unit 12, that is introduction to statistics. Is the slide visible to you now?
Yes, sir.
Okay. This is business statistics, univariate analysis. We will be discussing today about Unit 12, that is Introduction to Statistics. And if the time permits, then I will start with Unit 13 also, and which is measure of central tendency. That means what we will be talking about. We will be talking about something, or rather, we can say playing with numbers to get some result. It can be, and it is in the form of mean, mode, median, standard deviation, variation, quaternion deviation. These all things will be calculated, and we will be seeing where this statistics is used in your commerce path or in economics. First of all, we'll start with introduction to statistics. The word statistics has been used in a variety of ways. Sometimes it is used in the plural sense to refer the numerical statements of facts or data. On the other hand, it is also used in a singular sense to refer to a subject of study, like any other subject such as mathematics or economics. For instance, when we refer to a few statistics relating to our country, like there are 932 females per thousand males. In India, the per capita national product at certain prices has increased from rupees 246 in 1950-51 to rupees 2596 in rupees in 1985 to 86. Here we are using the word statistics in the plural sense, meaning data. To prepare these numerical statements, one must be familiar with those methods and techniques which are used in data collection, organization, presentation, analysis, and interpretation. A study of these methods and techniques is a science or statistics. The use of the word statistics here is in a singular sense. In this sense, the word statistics means statistical methods or the science of statistics. How statistics is defined in plural sense. In its plural connotation, statistics means data or numeral figures pertaining to any given situation or a phenomenon. These may be quantitative or qualitative data. What is meant by quantitative data? Quantitative data may represent the numerical observations in relation to a continuous variable. A continuous variable is the one which can assume any value between any 2 points on a line segment. All characteristics such as weight, length, height, thickness, velocity, temperature are the like and all continuous variables. Discrete data, on the other hand, refers to value assumed by a discrete. Then comes quantitative data. Quantitative data may be nominal or vector. The nominal data arises due to the classification into two or more categories of a certain number of terms, attending according to some quality characteristics. For example, characteristics of students according to sex, that is, a male and female, or according to the level of education, that is, matriculate, undergraduates, and postgraduates. Such data are also count data. The ranked data, on the other hand, are the result of assigning ranks according to the level of performance in any competitive test, contest, or interview. Statistics has been defined differently by different writers. According to Webster, statistics are the classified facts representing the conditions of the people in a state, especially those facts which can be stated in numbers or any tabular or classified arrangement. According to Bolle, numerical statements of facts in any department of enquiry placed in relation to each other. Then comes Yule and Kendall. They state statistics means quantitative data affected to a marked client by multiplicity of cases. These definitions are too narrow as they continue the scope of statistics to only such facts or figures which either relate to the conditions of the people in a state or specially some characteristics of the data. A more comprehensive definition of statistics was given by Horace Sequest. According to him, statistics means aggregate of facts affected to mandate extent by multiplicity of causes, numerically expressed, enumerated, or estimated according to a resonant standard of accuracy, collected in a systematic manner for a particular purpose and placed in relation to each other. This definition is quite comprehensive and points out the characteristics that numerical facts must possess so that they may be called statistics. What are the characteristics? They must be aggregate of facts. Individual isolated figures cannot be called as statistics. They should form a part of an aggregate of facts relating to any particular field of interest. Second one, they are affected by multiplicity of factors. There are several factors that affects a phenomenon. For instance, the consumption of a household on any item would be affected by several factors as income, taste, business, etc. Third one is they must be numerically expressed. To call a statement as statistics, it must be expressed numerically. Therefore, qualitative characteristics such as beauty, color, or eyes, etc., cannot be measured directly from here. In general, they do not all fall under the preview of fourth one is they are enumerated or estimated according to a reasonable standard of accuracy. Statistics are either enumerated or estimated, but reasonable standards of accuracy must be maintained. The degree of accuracy will depend on the future and the object of the study before and later. Fifth one is they must be collected in a systematic manner or for a predetermined purpose. The data should be collected in a specific manner. The data collected is a haphazard manner will not service your purpose. The purpose for which the data is collected must be decided in advance. The purpose should be specific and well defined. Next one is they must be placed in relation to each other. The numerical facts should be comparable if they are to be called statistics. For instance, statistics on production and export of a item during a year were needed. What they put together are statistics. It is clear that all statistics are numerical statements of facts, but all numerical statements of facts are not statistics. They will be called statistics only if only the above characteristics are present in them. What is statistics defined in single sense or singular sense? Numerical information must be collected, organized, presented, analyzed, and interpreted if it has to be used for making wise decisions. We require methods that help us in this regard. Thus, statistics, when used in a singular sense, has been defined as a body of methods which provides tools for the data collection, analysis, and interpretation. Bolly, for instance, has given a number of definitions, but none of them is comprehensive. They in fact points to the description of science of statistics over time. Some of the definitions are statistics may be called the source of counting. Statistics may highly be called the source of evidence. Statistics is the science of measurement of social organism regarded as a whole in all manifestations. Colton and Cowden. have given a simple and precise definition of statistics. According to them, statistics may be defined as the collection, presentation, analysis, and interpretation of numerical data. The definition given by Sally Graham is equally simple but comprehensive. According to him, statistics is the science which deals with the methods of collecting, classifying, presenting, accompanying, and interpreting numerical data collected to throw some light on any sphere of inquiry. The last two definitions are quite precise, comprehensive, and point out the scope of statistical methods. The science of statistics teaches us the method and techniques which are required for collection of data, classification and tabulation of data, presentation of data, analysis of data, and interpretation of data. Now, descriptive and inferential statistics. Statistics is the study of the principles and methods used in the collection, presentation, analysis, and interpretation of data in any sphere of inquiry. These methods and techniques are so diverse that statisticians generally categorize them into two: descriptive statistics and inferential statistics. Now, what is meant by descriptive statistics? This refers to various measures that are used to describe the characteristics features of the data. Such measures include measure of central tendency, measure of dispersion, etc. Graphs, tables, and charts display data are also examples of descriptive statistics. Suppose the number of first year BCom student is 100 and you compute the average marks of these students. Here you are using descriptive analysis or statistics. Then comes your inferential statistics. On the other hand, refers to the statistical process of drawing with inferences about the characteristics of postulates data on the time of sample data. The word population in statistics does not mean only the human population. It stands for totality of items related to any field of study in the market. Teacher, in the above example, decides to estimate the average marks of the entire class on the basis of average, a sample average. We would say that we have the inferential statistics. That means we are taking some sample of the sample from the data and we do mathematical calculations, statistical analysis, and after that we presume that whatever we have concluded is applicable to all the relative respective data. Now, what are the functions of statistics? Number one, to present facts in a proper form. Statistical methods present general statements in a precise and definite form. For example, you may say that in India, average yield of cotton per hectare is 183. This statement is more precise and convincing than saying the average yield of cotton in India is very low. That means the number specifies how much, what is the relation between what you are thinking. Second, to simplify unwidely and complexly. Statistical methods simply unwidely and complex data to make them understand easily. The raw data is often one cannot grasp their characteristics unless the data is classified according to some common characteristics. If you are given the weekly wages of 1,000 workers in a factory, you will not be in a position to draw any inference from the data unless they are condensed through classification as the following. That means we have to take start with something basic. So here we are talking about the wages. So wages will be in, no doubt it will be in rupees or in dollars. So it can start with below 600, 600 to 700, 700 to 800, 800 to 900, and above 900. In the second column, we see the number of the workers. That means now it is clear that how many people are getting how much money in which wage slab. Third one is to provide techniques for making comparisons. The primary purpose of statistics is to facilitate a comparative study of different phenomena, either over time or space. For instance, the estimate of the rational income is not done for its own sake, but it is done to compare the income over time to get the idea where the standard of living of people is rising or not. Fourth one is to study relationship between different phenomena. Statistical measures such as correlation and regression are used to study relationship between variables. Such relationships are important for making decisions. For instance, you may find a relationship between the demand of a product and its prices. Fifth one is to forecast future values. Some of the statistical techniques which are used for forecasting future values of the variable. On the basis of sales figure for the last 10 years, a marketing manager can estimate the likely demand for the period over the next year. To measure uncertainty, with the help of probability theory, you can measure the chances of occurrence of certain event. Probability concepts are quite useful in decision making. Suppose if you are interested in estimating the chance of your passing BCOM examination, you may get an idea about it by studying the past percentage of students during the last 10 years. That means you will be comparing two sets of information. Then comes to test a hypothesis. Statistical methods are extremely useful in formulating and testing hypotheses and for the development of new theories. For instance, a company is desirous of knowing the effectiveness of its new drug to control malaria. It could do so by using a statistical technique called T-square test. Then comes to draw valid inferences. Statistical methods are also used in drawing inferences regarding the characteristics the universe on the basis of sample data. Ninth one is to formulate policies in different fields. Statistical methods are very useful in formulating various policies in social, economic, and business. The government, for instance, utilizes vital statistical data for formulating timely peering programs. Similarly, the government utilizes the information on consumer price indices for regarding for granting DMS allowance to its employees. Now, what is the importance of statistics? In recent years, the scope of statistics has widened considerably to bring to its fold social and economic phenomena. The discrement in the statistical techniques over the years also widened the scope considerably. It is no longer considered to be a byproduct of the administrative setup of the state, but now it is embraces practically all sciences, social, physical, and natural science. As a matter of fact, though statistics finds its application in various diversified fields such as agriculture, business and industry, sociology, economics, trigonometry, biometry, and etc. Then these days, statistics find its application in almost all spheres of human activity. Statistics and state. In earlier times, the role of state was confined to the maintenance of law and order. For that purpose, it is used to collect data relating to manpower, crimes, income, and wealth, etc. For formulating suitable military and fiscal policies. Today, statistical data related to prices, production, consumption, income and expenditure, etc., are extensively used by the governments world over for formulating their economic and other policies to raise the standard of living of its population. Developing countries such as India are following the policies of planned economic development. For that purpose, the government must base its decision on correct and sound analysis of the statistical data. For instance, in formulating its 5-year plan, the government must have an idea about the availability of raw material, capital goods, financial resources, the distribution of population according to the various outcomes such as age, sex, income, etc., to evolve various policies. Statistics in economics. Statistical analysis is immensely useful in the solution of a variety of economic problems such as production, consumption, distribution, etc. Data on prices, wages, consumption, savings and investment, etc., are vital in formulating various economic policies. Likewise, data on natural income and wealth are useful in formulating policies for reducing the disparities of income. Use of statistics in economics has led to the formulation of several economic laws, such as the Agil's law of consumption, law of income distribution, etc. Statistical tools of index numbers, time series analysis, regression analysis, etc., are vital in economic planning. Then comes statistics in business and management. With the growing size and increasing consumption, the activities of modern business enterprises are becoming more complex and demanding. The separation of ownership and management in the case of big enterprises has resulted in the emergence of professional management. The success of managerial decision-making depends upon the timely availability of relevant information much of which comes from statistical data. Statistical data has therefore been increasingly used in business and industry in all operations like sales, purchases, production, marketing, finance, etc. Statistical methods are now widely adopted in market and production research, investment policies, quality control of manufactured products, economic forecasting, auditing, and many other fields. One element common to all the problems faced by managers is the need to have decisions under uncertainty, and the statistical methods provide technique to deal with such situations. It is therefore not surprising when Walls and Roberts when were when Walls and Roberts say that the statistics may be regarded as body of methods for making wise decisions in the face of uncertainty. What are the limitations of statistics? And everything has plus points, then it also has a negative point. In spite of other functions, statistics has its own limitation. These limitations should be kept in mind while making use of various statistical methods. And some of the limitations of statistics are: statistics deals only with the quantitative characteristics. Statistics deals with the facts, which are expressed in numerical terms. Therefore, those phenomena that can be described in numerical terms do not fall under the scope of statistics. Beauty, color of eyes, intelligence, etc. are quantitative characteristics and hence cannot be studied directly. These characteristics can be studied only indirectly by expressing them numerically over the assigning particular source. Statistics does not deal with individuals. Since statistics deals with aggregate of facts, a single and isolated figure cannot be regarded as statistics. For example, the height of one individual is not of much relevance, but the average height of a group of people is relevant from statistical point of view. Number three, statistics law are not exact. Unlike the law of natural science, statistics laws are not exact. They are true under certain conditions and always have some chance factors associated with them for being true. Therefore, conclusions based on them are only appropriate and not real. They cannot be applied universally. Fourth one is statistical results are true only on an average. Statistical methods reveal only the average behavior of the phenomena. The average income of employees of a company will therefore not throw much light on the income of a specific individual. They are therefore useful for studying a general appraisal of a phenomenon. Then comes statistics is only one of the methods of studying a problem. A problem can be studied by several methods. Statistical methods are only for one of them. Under all circumstances, statistical tools do not provide the best solution. Quite often it is necessary to consider a problem in light of social consideration like culture, region, etc. Therefore, statistical conclusions need to be supplemented by other evidence. Statistics cannot be misused. The various statistical methods have their own limitations. If used without caution, they are subject to wrong conclusions. So, one of the main limitations of statistics is that if put into wrong hands, it can be misused. This misuse can be at times accident or intent. Many government agencies and research organizations are tempted to use statistics to mispresent, mis, misrepresent the facts to prove their point of view. Then comes classification according to variables. Variables refers to quantitative characteristics of data and can be expressed numerically. Example of variables are wages, age, height, weight, males, distances, etc. As you know, all these variables can be expressed in quantitative terms. In this form of classification, the data is shown in the form of frequency distribution. A frequency distribution is a tabular presentation that generally organizes the data into classes and shows the number of observations, that is frequencies, falling into each of these classes. Based on the number of variables used, there are three categories of frequency distribution. First one is univariate frequency distribution, second one is bivariate frequency distribution, and the third one is multivariate frequency distribution. What is meant by univariate frequency distribution? The frequency distribution with one variable is called a univariate frequency distribution. For example, the students in a class may be classified on the basis of marks obtained by them. Second one is bivariate frequency distribution. The frequency distribution with two variables is called bivariate distribution. If a frequency distribution shows two variables, that is marks in statistics and age, it is known as the trivariable frequency distribution. Now we move to Unit 13, that is measure of central tendency. What is the concept of central tendency? For a proper perception of various statistical measures used in analyzing a frequency distribution, it is to note that some of the senior some necessary to note that most of the statistical distributions have some common features. If we move from lowest value to the highest value of a variable, the number of items at each successive stage increases till we reach a maximum value, and then we proceed further. They decrease. The statistical data which follow this general pattern may differ from one variable to another in the following three ways. First one, they may differ in the values of the variables around which most of the items clusters, that is the average. Second one, they may differ in the extent to which the items are dispersed, that is dispersion. They may differ in the extent of departure from some standard distribution called normal distribution, which includes skewness and kurtosis. Now, let us discuss the first set of measures, which are called averages or measure of central tendency or measure of symmetry. What is the definition of central tendency? Clark defined it as average is an attempt to find one single figure to describe whole of the figure. Croxton and Cowden defined an average value is a single value within the range of the data which is used to represent all the values in the series. Since an average is somewhere within the range of the data, it is sometimes called as the measure of central value or measure of central tendency. What are the objectives of average or central tendency? To supply one single value that describes the characteristics of the entire data. An average reduces the complex mass of data into a single representative value, which enables us to grasp the salient features of the data without getting lost in its detail. Thousands of lakhs of values can be thus represented by a single value. To facilitate comparison, it is the most easy. It is not easy to compare the two sets of huge raw data, but the two different data sets could be easily compared by working out their averages. Comparison can be made either at the part of time or over a period of time. Third one is to facilitate statistical inferences. To draw inferences about the known measures or parameters of the population, we depend on values calculated from samples. The process is known as statistical inference, and the average obtained from a sample is helpful in understanding the average of the population. Fourth one, to help the decision-making process. The averages are computed to help the managers in decision making. The managers are often interested in knowing normal output of a plant, representative sales volume, and overall productivity index, price index, etc. These all are the definitions of an average. What is the essential of an ideal average? As suggested by the eminent statisticians Rule and Kendall, an average ideal should possess the following characteristics. Number one, easy to understand and simple to compute, rigidly defined. It should be based on items in the data, not to be unduly affected by extreme items, capable of further algebraic treatment and sample. Now, different measures of central tendency. Following are the various measures of averages or central tendency. If we talk about mathematical averages, it includes geometric mean, arithmetic mean, and harmonic mean. And if we talk in terms of averages of position, that is median, partial values, which includes quartile, deciles, and percentiles. And the third one is mode. All these measures can be either simple or weighted. What is meant by arithmetic mean? The word average we use every frequently in day-to-day expressions, such as average price, average income, average weight, etc. In these expressions, the word average is nothing but arithmetic mean, generally in layman's called an average, but statisticals called them the arithmetic mean. Or in the simplest word, we can say the a particular number around which all other numbers are present. The arithmetic mean is commonly known as mean. It is a measure of central tendency because other figures of the data migrate around it. Arithmetic mean is obtained by dividing the sum of values of the observations in the given data by the number of observations in that set. It is the most commonly used statistical average in the discipline such as commerce, management, economics, finance, production, etc. The arithmetic mean is also called the simple arithmetic mean. Now, the mathematical part starts. Computation of arithmetic mean. As you know, the collected data is classified by arranging into different classes or groups on the basis of the similarities and resemblances. Arithmetic mean can be computed for the unclassified or ungrouped data, what we call it as raw data, as well as classified or grouped data, but the method of computations are different. Arithmetic mean is represented by x bar, x and bar over it. You can see here. We will start with ungrouped data. Ungrouped data method 1. Computation of arithmetic mean is very simple when the data is ungrouped. That is, when frequency distribution is not done. Just add all the values of the observations and divide it by the number of the observations. Or in the simple terms, we can say that mean is sum of all the observations divided by number of observations. Your observations are x1, x2 till xn, and number of observations are given by n. So your x bar will be equal to x1 plus x2 till xn divided by n. Or in the terms of summation form, we can write as x bar is equal to summation x1 xi upon n. Number 2, when the values of the observation in the given data are too large or they are in fractions, this method may be followed. This method is based on the facts that the algebraic sum of the deviations of the series of individual observations from their mean is always equal to 0. To compute arithmetic mean under this method, the following steps are to be followed. Number 1, assume any arbitrary mean A to find out the deviations of items from their assumed mean. Number 2, compute the deviation, that is small d, from the individual value x, which is termed as d is equal to x minus a. Then obtain the sum of all the deviations. That means summation d will be 0. And then compute the arithmetic mean by using the formula x bar equal to a plus summation d upon n. We will see how this mathematical or arithmetical mean is calculated when your data is raw. You can see that you are being asked to calculate the average sales per month. There are number of dealers 10, starting from 1, 2, 3, 4 till 10. And their sales observation is given as 23, 8, 14, 31, 6, 28, 11, and 46. We will write them in a column form. The first column will be dealer 1 to 10, your n is equal to 10. Second will be the sales. Whatever the values are given will be written in front of the respective dealer. Now, this D is calculated. Assume mean is 25. Summation D, because here the frequencies are more. So there are two ways to calculate this. You can do one thing in spite of doing going by this method. Just tell me, just add all these numbers 28, 23, 8, 14, 31, 6, 28, 11, 27, 32, and 46. Do you hold copy and pen with you?
Yes, sir.
Please add all these numbers 23, 8, 14, 31, 6, 28, 11, 27, 32, and 46. And tell me what you are getting.
Uh, 23 plus 8 plus 14 plus 21 plus 6 plus 28 plus 11 plus 27 plus 32 plus 46 is 226.
226. And what is
Yes.
the number of observations?
Yes,
Now see, I'm telling you, I'm showing you one more thing. You told me that you are getting the sum of all these numbers as 226. Correct?
yeah.
How many observations are there? There are 10 observations. There are 10 dealers.
Yes, then it is 10 figures, sir.
There are 10 dealers. The number is written in uh, at the top. Divide this 226 by 10.
Okay, sir.
How much you are getting?
I'm coming, sir. 90.
22.6.
22.6. Now see,
Yes.
I have applied a different method and your slide shows different method. You are getting the same answer. Got it? We have
Yes, sir.
we have this formula also. Here the thing is that we have to assume something, some value. And this will be, you just remember this formula. X bar is equal to A plus summation D upon N. I will show you another problem. Okay, later on we will see to the problem. Now if the data is grouped, this was a raw data. Now this the another form is when the data is grouped. Variables can be categorized as discrete variables and continuous variables. The frequency distribution prepared for discrete variables is called discrete distribution, and the frequency distribution prepared for continuous variable is called continuous distribution. Method of computing arithmetic mean for these two types of distributions are different. Now see, first for discrete series. Method 1, it is also called direct method. Under this method, the mean for group data can be obtained by using the following relation. That means x bar is equal to summation fx upon summation f or summation fx divided by n. This is the formula which is normally applied. Summation fx upon n or summation fx upon summation f. The second one is the shortcut method. When the number of classes in the given frequency distribution is large, there is a difference. When the frequency is large, then we apply this formula. The procedure followed in this method is almost the same as it was in the ungrouped data. Steps to be followed. Here, what we are going to do, we are going to assume a mean, normally a central value. We have to calculate d is equal to x minus a. Then we have to calculate summation of fd. That means frequency multiplied by this d. Then we have to obtain summation f. And then we have to apply the formula x bar is equal to a plus summation fd upon summation f. Now, be prepared with your pen and pencil and see to it. The problem is calculate the arithmetic mean of the following data by using two methods. The problem consists of the marks and the number of students. Suppose there are 8 students who got 10 marks, 21 students who got 20 marks, and respectively this data is given to you. Now we will be using two methods to calculate the mean, and in both the methods you will get the same mean. Now, what is this method? First of all, write marks in the column form 10, 20, 30, 40, 50, 60, 70, 80. Then write the frequency, that is number of students. Number of students is here in this problem as frequency. 8, 21, 23, 17, 15, 9, 5, 2. Sum all these numbers. That is summation f is equal to 100. Now, what to do? Straight away, the first method says multiply f into x. Go back to the last column. 10 into 8 is 80. 20 into 21 is 420. 30 into 23 is 690. Similarly, you will be getting all these values. Add all these values of fx. You will get as 3670. What is the formula for us? What we are aware of? H bar is equal to summation fx upon summation f or n. Here, summation fx is 3670 divided by 100. You get 36.70. This was the first method. Now, what to do for the second method? Your second method is have a look at the marks value of x. What is the value at the center of this table? We can take a as 40 in this problem. Okay. Now, I tell you in this column d is equal to x minus 40 has to be generated. So in straight away you have to subtract these values of 10, 20, 30, 40, 50, 60, 70 and 80 from 40. So you will get minus 10, minus 20, minus 30 over the top, and below you will get 10, 20, 30, and 40. Now multiply FD. FD means 8 into minus 30, which comes out to be minus 240. Then 21 into minus 240, 21 into minus 20, that is minus 420. 23 into minus 10 is minus 230. 17 into 0 is 0. 15 into 10 is 150. 9 into 20 is 180. 5 into 30 is 150. And 2 into 40 is 80. Add all these values. You get minus 330. Now, since you have assumed, so we have to apply another formula which includes assumption. That is method 2, x bar is equal to a plus summation fd upon n. Your a is 40, your fd is minus 330, and your n is 100. What you will get? 40 minus 3.30, which comes out to be 336.70. Is that correct? By both applying both methods, you are getting the same value. Now, in nutshell, I will tell you, if the frequency numbers are in double digits, here you can say, yes, sir, please.
Sir, please,
Yeah.
please, and I need more explanation.
What is your question, please?
This table,
Sorry, I didn't get
yes,
you.
sir. This table is
Should I
left
repeat it?
behind. I need more. Yeah, yeah, sir.
Okay, fine. The problem is given to you that you have to calculate the arithmetic mean of the this data by using two methods. So I will be writing this data into columns. First of all, I will write marks. I will copy it from the question 10, 20, 30, 40, 50, 60, 70, and 80. Then in the second column, I will write the number of students, which will be similar to what in statistics form we call it as frequency. I will copy all these numbers 8, 21, 23, 17, 15, 9, 5, and 2. Now, there are two methods for calculating the arithmetic mean. The first method is summation. You can see on the right hand side of your screen that method 1 is x bar equal to summation fx upon n. Now, marks are denoted by x and number of students are denoted by f. So you have to calculate fx. On the last column, you can see fx is written. Multiply 8 into 10, you get 80. 21 into 20, 420. 23 into 30, 690. 20 into 17, 680. 15 into 50 into 15, 750. 60 into 9,
364.
70 into 5, 350. And 80 into 2 is 160. Add all these numbers, you will get 3670. As our formula is x bar equal to summation fx upon n, we have summation fx as 3670 and your n is 100. N or summation f means the same thing. That means 3670 divided by 100 comes out to be 36.70. That is the mean by the first method. Now we move to second method. In second method, we have to assume. That means we have to assume a mean. Here in this particular problem, or normally what we do, we assume the central value in the first column. In this particular problem, we are assuming A as 40. Since you are assuming A, so you have to find D. D is nothing but x minus A. Your A is 40, so you will be subtracting x minus all the values of x, column x by 40. So we will start with 10 minus 40 is minus 30, 20 minus 40 is minus 20, 30 minus 40 is minus 10, 40 minus 40 is 0, 50 minus 40 is 10, 60 minus 40 is 20, 70 minus 40 is 30, and 80 minus 40 is 40. Now, you have to multiply f and d. 80 into minus 30 is minus 240. 21 into minus 20 is 420, as we will be calculating till the last. That is 20 into 40, which comes out to be 80. Now, we will be adding all these values. After summation, we get summation FD equal to minus 330. Going back to the formula for method 2, x bar is equal to A plus summation FD upon n. Your A, what you have assumed is 40, summation FD is minus 330, and your n is 100. Putting up all these values in the formula, you will get 40 minus 3.30, which comes out to be 36.70 marks, which is same as what the mean you have obtained by method 1. Now you have understood it.
Yes, sir.
Now I won't be starting method 3, which is I can give an introduction to you, but I want that during a period of 1 week, you should go through your material, study material once, and try to understand, because method 3 is a defined form of method 2. That is too easier, and if you have understood method 2, you will be in a position to solve the problems with 3. Because normally, in the later on of your studies or in different papers or courses, the third method will be applied, which is easier to in that it is easier method to calculate the mean, and normally we apply 90% of the cases that method. That is a refined form of method number 2. So I will be stopping over here today. Any questions from anyone?
No questions, sir.
Madam, speak loudly, I
No
can't hear you.
question from me, sir.
Okay, this is one of the most important part. Be careful, do it. You have a period of time, do it. If you don't understand anything, just let me know, because I will be repeating this problem before starting unit 3, method 3, because formula remains, I will show you the formula remains the same, but there is an introduction of a factor I. That's it.
Okay, sir.
I will be starting with factor method 3 next week. Till now, till then, please go through the study material. It will be easier for you to understand it, because it is mathematics, statistics. You have to do it with your own hands.
All right, sir.
Okay,
Bye, sir.
so I will
Thank
be taking leave for the day. Thank
you,
you.
sir.
Bye bye.
Thank you, sir.